Welcome to this video on SQL Full Join. Today, we are diving deep into the concept of combining records from two or more tables using SQL. Full Join is a powerful tool when you need to see all the data from your tables, regardless of whether there is a match between them. This is a very handy tool. Let's get started. Let's understand what a full join is. A full join returns all records when there is a match in either the left or right table. It combines the results of both left join and right join, including all matching records, all non-matching records from the left table, and all non-matching records from the right table. Here's the basic syntax of a full join. Select columns from Table 1. Full join Table 2 on Table 1. Column name equals Table 2. Column name. Alternatively, you can use the syntax. Select columns from Table 1. Full outer join Table 2 on Table 1. Column name equals Table 2. Column name. Let's visualize the concept of a full join. A full join returns the entire set from both tables. Where records match on the join condition, the fields from both tables are returned. Where there's no match, the fields from the non-matching table contain null values. In the Venn diagram, the left circle represents Table A, the right circle represents Table B. The area that are only in Table A are records that are only in Table A. The middle part are matching records, and the area that only in Table B are records that are only in Table B. Let us look at the sample tables for our full join example. On the left, we have a table named Departments with columns department_ID, department_name, and location. It contains sample data for the engineering, marketing, finance, and HR departments. On the right, we have the Employees table, which includes columns EMP_ID, EMP_name, and department_ID. It includes data for Alice, Bob, Carol, and Dave. It's worth noting that Carol has a department_ID of 105, which does not exist in the departments table. Dave has a null department_ID. Also, the HR department 104 has no employees. We will see how full join handles these mismatches in our example. Here's a basic full join example. The query is to combine the departments and employees tables. Select D.department_ID, D.department_name, D.location, E.emp_ID, and EMP_name from departments as D. Full join employees as E.department_ID equals .department_ID, order by D.department_ID and EMP_ID. Here's the result set. As you can see, all the records from both tables are included. For departments without employees and employees without department, the corresponding columns display null values. Let us understand the full join results. Records where department_ID matches in both tables show data from both tables, for example Alice, who works in engineering, department_ID 101, and Bob, who works in marketing, department_ID 102. Finance, department_ID 103, and HR, department_ID 104 departments don't have any matching employees, so employee columns show null values for these rows. Carol has a department_ID of 105, which does not exist in the departments table, and Dave has a null department_ID. So department columns show null values for both these employees. Key takeaway: full join is ideal when you need to see all records from both tables, regardless of whether there are matching values in the related columns. It's particularly useful for data validation, finding orphaned records, or creating comprehensive reports. Full join is not just a theoretical concept. There are a number of practical use cases for the same. Let's see some of them. 1. Data validation and integrity. You can identify orphaned records or data inconsistencies between related tables. Use where conditions to find records that exist in one table but not the other. For example, where Table 1.id is null or Table 2.id is null. 2. Comprehensive reporting. You can generate complete reports that include all possible records from both datasets, ensuring no data is excluded regardless of matching status. Ideal for executive dashboards and auditing requirements. 3. Data migration and ETL. During system migrations, use full join to compare source and target databases to ensure all records are properly transferred. Identify missing or duplicate records in either system. 4. Trend analysis with sparse data. When analyzing time series data where some periods might not have entries, full join helps create a complete timeline with placeholders for missing data points. Especially useful in financial reporting and forecasting. In summary, a full join returns all records when there is a match in either the left or right table. If no match exists, null values are used for the columns from the table without a match. Full join is synonymous with full outer join in most SQL databases. It's great for data integrity checks, finding orphaned records, and comprehensive reporting. It is not supported in all database systems. Let us compare different types of joins. Inner join returns only matching records. Left join returns matching records and left-only records. Right join returns matching records and right-only records. Full join returns all the records. Cross join returns all the combinations between the tables. Full join is the most inclusive of all join types. Use filters where to narrow down results when needed. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.